Hey guys, it's Simon and welcome back to another video about the Fleks entity component system in Kotlin. So it's now, well, I don't know, 3 months or 4 months since the last video, and there was a lot of progress actually with this library because there were a couple of releases. I will go through the most important changes that were made there, but I will also show you the game that I made. So I called it Dinoleon, which is the combination of a dinosaur and a chameleon. I showed it in a moment how it looks like, and there I made a small game, which in my opinion, the way I did it, you should not do that for that game. So I made it very complicated because I used a physics engine. I used Scene2D from libgdx with a couple of features and a few other things which are totally not necessary for an easy game like that. But of course, I wanted to challenge the Fleks entity component system, so I did that on purpose, and I'm glad that I did that because if I wouldn't have done that, then certain things I wouldn't have discovered, and some functionality which I find quite useful, and hopefully others find it as well quite useful, would be missing. So first of all, let me show you the game. So the controls are Q, you change the dinosaur to the color red, W to the color green, E to the color blue, and R to the color orange. You see in a moment what that means. I will add the links to the video description for the game and also, of course, for the Fleks library. But let me quickly show it to you. So you can choose between 3 different difficulties, so easy, medium, and hard. I'm only able to do the easy challenge. If someone out there is able to do the medium or hard challenge, let me know. And how does it work? So you click on that, then from the right side there are these walls. When the dinosaur doesn't have the correct color, then it takes damage. You can take up to 5 hits. After that, so when the color is the same, then you don't get damage, and after the 5 hits you are done. We didn't get any star because we obviously didn't beat it. We can retry, which we want to do now, and now I will concentrate a little bit. So blue, fuck, then that one, then red, orange, red, green, blue, red, green, blue, red, green, red, orange. Ta-da! 3 stars, perfect. Now we can click here. We could go to a different challenge, but that's it. So you have seen the game. It's really quite simple. And again, using a physics system and the sensors and whatever I did there, you shouldn't do that for a game, but this is really to demonstrate the power of the Fleks entity component system. And you can use that as a reference to look up how I did. So personally, I was very happy about how it felt. So when using it, it felt fast to develop certain systems. Also, how to create the components and everything was really easy to do. I did not need this remove system that I always needed with Ashley, because I was confident that the way how entities are created and removed is working out, which actually didn't. There were quite some bugs in it, but I solved all of them, and in the end I did not need this annoying remove system, for example. And felt for me personally really good. So what has changed since the last time? I think we left with the pre-release version, if I remember correctly, maybe also the alpha version, not sure. But I for sure know that on my holiday I released a release candidate 1 version where I updated certain versions, this log4j vulnerability stuff, which we don't really care about, but it was solved with that. And one of the nice features was this pose functionality, which especially with a libgdx game is useful, but might be useful with other applications as well. So what you can do for the people out there who know libgdx, when you have a system, you can create certain resources which need to be disposed. Like for example, here in my debug system, I have a box2d debug renderer, and every system can override this on dispose method, which is optional, but you can override it. and then you could dispose the resources that this system is creating. So that way I don't need to pass in the physics renderer from the outside and dispose it from the outside, or need to write my own logic to somehow dispose resources from systems. This is now officially supported with Fleks. So whenever you dispose the world, then all the systems also get disposed with that method. And with that, you can easily achieve things like that, that simply you allocate the resources that you need in your systems, and when you want to get rid of them, then you do that in the dispose method. So this was one of the features that I was missing in Ashley as well, and that's why I added it now to Fleks, because it's a use case that I often had in my game developments. The next one is the component listener, which was completely missing, and I found that out because I used Box2D. So here the use case was that sometimes a component is not simply data that you set. Sometimes it's also allocating certain resources and need to be then cleaned up when the component gets removed from an entity. Like for Box2D, for example, you usually have this body, and when a component loses the physics component in that case, then the body should be destroyed to free the resources which were allocated by that. And this can be solved in Fleks with a component listener, where you specify for which component you want to have that. So for me, the cleanest solution was for the physics component. There I simply have a companion object with the component listener. This class, of course, could also be moved outside, doesn't really matter. In the end, you get there two methods, the component added and component removed, where you always get called when an entity gets this component added. Then you can do something like, for example, set the user data of the body, or you get called when the component gets removed. And in that case, for example, I destroy the body from the world and also clear the user data. So this listener functionality that you can react on when a component gets added or removed was completely missing. And that was then also added to support that. Then in the second version, I supported then the possibility that you can add a qualifier annotation when it comes to dependency injection, and you want to inject the same class, let's say, multiple times to different systems. So I think in the game screen, yes, so here I prepared something in the comments. So imagine you have a stage, a scene 2D stage, one for the game itself and one for the user interface. So you would inject that to Fleks, so inject the game stage and inject the UI stage. But in a system, when you use it, like before it was like this without that one, so something like that, how would the dependency injection know which stage to choose? So should it inject here the game stage or the UI stage? So it's the same class, it's a stage, but we have multiple instances of those, so how to inject it. And there I read a little bit, and in the end I went for this annotation approach, where you can say with a qualifier what kind of dependency you want to inject. So like in this case, the UI stage gets the name UI stage, and the game stage gets the name game stage. And then here, for example, for that system, if I say I want here the UI stage, then the dependency injection will choose that one which gets injected into the system. In the end, I think I never needed it for that project. Let me quickly check. No, I never needed it because I could work around the cases where I would have needed it. But again, I think it's something that is useful, and definitely there will be cases where you will need that, or I will need that. So that's why I added that with this qualifier annotation, that this is then also supported. Another thing which I think I also did not need then in the end, but I found out because it's a tricky bug to identify, was the problem. Let me go to just a random system. So in Kotlin, usually when you want to add certain logic to your constructor, then you use this init block. And in there, since we are inside a system, you have access to the entity world, with which you can create new entities and things like that. but the world actually is not set at that point in time. This is simply impossible with the way it works in the background when it creates systems and so on. So the world will always be null. And before there was actually a strange, it was really a bug, because I created like an empty world instance in the library itself and used that for the null safety. So the world was not throwing a null pointer exception, and you could write things like that. So add an entity to the world, but that world was actually the empty world of the library and not your own world instance. So this was really a tricky bug to find out. And to solve that, I introduced now an onInit method, and in there you really have access to the world. And in addition, I also made it obvious. So if in here you would use the world, then here now that really throws an exception. I forgot which one. I think Kotlin not initialized exception or something like that. So I think a standard exception that the user knows that he's doing something wrong. Again, in the end, I didn't need it that, but I think it's also useful in certain cases if you need special initialization logic for your system where you already need the world. Okay, then of course, as always, bug fixes, some minor things, and one final minor release was this release candidate 3 with this add or update function, which I needed. Let me also show you that one. So like here, what this is replacing is normally the redundant block that I had to write with Ashley multiple times, where you check, is the component part of an entity? If yes, give me that component and modify the values. If not, create a new component and set the initial values. And instead of having that block, it's simply now this method, so add or update, and as the name says, if the damage component would be already existing, then it simply gets that and modifies it. So in this case, it increases the damage that the dinosaur will take. And if it's not existing yet, then it will create a new damage component and also set the damage then to 1 because the initial value is 0. So that simplifies that a little bit. That is like a utility function, I would say. Yeah, I think that is the most important part about that. One thing about Fleks where I'm very grateful is that we have now, I would say, a stable version for now for the JVM platform. So for Java, for JVM stuff, and for Android, I think it should also work. For web, iOS, and maybe native stuff, it won't work with that specific version. But we also have now a multi-platform version soon available, so hopefully end of this week or next week, where the API is slightly different because some adjustments had to be made with the annotation processing, and the reflection part could not really be used. And there, thanks again to that specific guy who helped out with that, so Job M. Marco Koschek, from Germany, I just noticed now. So thanks a lot to this guy, because he was doing that all on his own. So he made the multi-platform branch, converted everything that it works in a multi-platform environment, meaning that you could use it, for example, with the Korge, so the Kotlin game engine. And in general, I always had the idea to make it then in the end multi-platform, because I think that would be the future, because then you can use Fleks in virtually any platform that you want to target. That's great. Wouldn't say I'm not sad, but what is not 100% perfect yet. So of course the API had to change a little bit, because not everything was possible with the way I did it with the JVM backend. And currently one special feature is missing, where he's working on, but that should also soon work. And then I think for sure I will release that version as a separate one on Maven Central. So all of that you can then find in the README and so on. And this will just live in parallel for now. So we will have the version for the JVM backend with a, would say, slightly easier API, and we have then the multi-platform version with a slightly different API, not very complicated, but just slightly different. The upside is it's actually faster in some of the benchmarks, so especially the complex benchmarks. So as you can see it here, so with the multi-platform branch it was 1.3, and with the current branch or version it's 1.2. That doesn't look like a lot, but actually it is a lot, this 0.1 improvement here. And of course in the future, but I cannot tell you when that is, I want to combine it again, so to only have one version, which is then the correct one, let's say, and that for sure will be the multi-platform branch. But there I want to read a little bit in annotation processing, because with that, from what I understood so far, it would be possible to get almost the same API again than with the JVM version currently. And actually it should also be then faster and easier, because the reflection part would not be necessary, because the annotation processing is doing that already during compile time, if I know that correctly, but I'm not an expert yet with the topic. So that would be the goal of this library in the end, to have then just one version, a multi-platform version, and most likely with this annotation processing, and then I would be 100% happy with the library. But that's it. I talked quite a lot. I hope I did not bore you. Thanks for watching, for listening, and have a nice rest of the week. Bye bye.